Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Electrophilic aromatic substitution, Friedel-Crafts type alkylation, via protonation of an alkene by a strong acid to generate a carbocation, which then acts as an electrophile toward benzene. Step 1. Protonation of cyclohexene, concentrated H2SO4 protonates the double bond of cyclohexene according to Markovnikov's rule, generating the cyclohexyl carbocation, a secondary carbocation at C1 of the cyclohexane ring. Step 2. Electrophilic attack on benzene. The cyclohexyl carbocation is a good electrophile. It attacks the pi system of benzene, electrophilic aromatic substitution. The arenium ion, sigma complex, intermediate then loses a proton to regenerate the aromatic ring. Step 3. Product. The result is cyclohexbenzene, a benzene ring bearing a cyclohexyl substituent. This is the sole major organic product after the acid is washed away and excess benzene is removed. Why other options fail? B. 1. Cyclohexylcyclohexane would require cyclohexene acting as the nucleophile toward the carbocation rather than benzene, but benzene is present in large excess and is a much better nucleophile in this context. Also, the reaction would generate another carbocation rather than a stable product without further steps. C. Trans 1,2 diphenylcyclohexane would require two phenyl groups adding across the double bond, which is not the mechanism here. D. 1,1 diphenylcyclohexane would require two benzene rings adding to the same carbon, inconsistent with the straightforward monoalkylation occurring under these mild, 0 degrees Celsius, conditions. Therefore, the correct answer is A. Therefore, the correct answer is option A.